Inox Green Energy Services Limited to kindly join us here on the dais. A big round of applause, ladies and gentlemen. With this, I would hand over the dais to our esteemed moderator, Mr. Mradul Chadha, to kindly take this session forward.
Good afternoon, everyone. I welcome you all, especially our esteemed panelists. Uh, Thank you so much for joining us today. As the title of the session mentions, we are here to discuss about the technical and quality standards of BOS systems in utility scale solar projects. Uh, Before diving into the questions, the queries, and discussion with our panelists, I would just like to inform that Bridge to India, my company, in association with the International Copper Alliance, had issued a report earlier this year, which looked into the challenges and possible solutions with respect to the technical and quality standards for BOS systems. So I would request every one of you to have a look at that report that is publicly available. And with that, I'll begin the discussion. I'll start with Mr. Reddy. As SECI sits at the start of the value chain of the solar project development. Mr. Reddy, with respect to the standards mentioned within the tender documents, we have seen that the rooftop tenders are much more detailed in terms of quality standard requirements for developers, but that is not the case for utility scale standards. I would first like to understand why that is, what kind of challenges are there for a tendering agency to include some of these standards within the tender documents, and in the actual implementation by the project developers, if you have seen any challenges, any quality issues.
Yes. Okay, thank you, Brazil. It's actually I congratulate Bridge to India for bringing a nice report actually, which is close to our heart also actually, because as implementing agency, it's our prime duty to ensure the quality also. Okay, that is the thing. Brazil, as you were saying that in the rooftop, we mentioned that we have our detailed specifications are there. In the utility scale, large scale projects, we have given basic standards for modules, inverters, and something on mounting structures also we have given recently, but not very detailed. Okay, the idea here is that because our duty is to just to take the power and pay them the money, and the quality assurance or ensuring quality is it's the investors' duty actually. So initially when we started with some specifications, always some arguments are there. Complying the things is a big thing actually. So we realized that even later stage also, and then we worked with some agencies from Germany also. Even we worked with some funding agencies also, because the lenders are the more sufferer if the project is of poor quality means lenders are the more sufferers. So we are working with lenders, IREDA, SECI and other lenders also we are working with them. And we compiled a guidelines also. Soon we'll be publishing that. But your report is very well drafted and comprehensive. But as I'm saying that there are something mentioned, you mentioned 2-3 things in the report. One is BA standards are not, it's just beyond I think 6 years or 4 years beyond the current standards of IEC standards. I personally means I am the chairman of the committee now. So in the recent meeting, I took it with the BAS people also. We have to bridge that gap. We want to immediately adopt the standards, international standards. If there is any comments in straight away adoption, we have first let us publish and take comments of the stakeholders, then we can modify. So soon I think that we means personally I am taking it as to address that, bridging that gap. Means immediately we'll be adopting the new standards. So that is one thing. The other thing is that functional items, people are having pretty good standards are there. Okay, so people are following even the, let us say, solar module and inverter. They have the standards, they have the certifications, but non-functional things are there. Let us say you mentioned that in the structures, you are saying that a rectangular type of loading or uniform loading is not the thing, and triangular loading should be there. In Seki, we develop our own projects also. Wherever we mentioned that, we ask for the compliance of that, we get very stiff resistance from the EPC contractors. No, this is not like industry is following these type of things. Okay, so your structures are so heavy like that. But what we say that structure cost is just 5%. Even if I increase some loading on it, maybe it may go to 7%, but my 60-70% is lying on the that 5%. We should not forget that, but it is very difficult now because it is not a controlled. We can only give suggestive things, we cannot control anything. Instead, in your remarks, I think maybe in future reports, if you can think of having a rating agency for the, like BE star rating is there for the products, like projects rating agency is there. After all complying this standards, this is of this rating project, and something like that. If an agency comes, if the rating process comes, no, then it will be easy for the lenders also. I think they can easily, some good rated project, they can, without any thinking, they can fund also, they can maybe for refinancing, all these things, they can do it easily. So many things to have to be happened. Okay, so we are also working on it. Let us hope the things will get streamlined soon. Okay, thank you.
Mr. Mathusudan, Mr. Reddy said that there are a number of standards which the developers can follow. Indeed, there is a plethora of standards, BIS, IEC, IEEE. As a developer, how would that company strike a balance between following the best standards yet looking at achieving a healthy return on investment? Because we have seen that the tariffs have declined sharply, even though the capital cost has increased over the recent quarters. So how big a challenge is that for a developer?
Okay. Anyway, it's thanks for a good opportunity for a meeting great people here, and it's a nice session to begin with. So, from a developer perspective, let me introduce myself and experience. I have worked with previously SoftBank Energy, which developed around 4 gigawatt operational and 7 gigawatt in total pipeline in India and 1.7 gigawatt in US. So, and recently I worked in Blue Pine Energy, where I was participating in bidding auction, and we won a recent 100 megawatt, 120 megawatt in Gujarat. So, from observing from a developer perspective, I'm giving my opinion. Okay, there is nothing hard and fast here. Every company have their own way of looking at things differently, right? And right now, as we know, the tariff is coming very low. The developers are starting taking too many financial risk in taking that. 5 years down the line, when we observe the amount of returns they were making at a very less risk. And right now the risk has increased, but the tariff is reduced, and people have compromised their returns also. So now the challenges, not only in terms of making a BOS design specification, if you take modules, if you ask what will be the module price after 1 year, after 2 years, it's a prediction. And right now in global markets, without knowing which module is going to get into your project, a structured design, whether it will be a bifacial tracker, or it's a monofacial, or a fixed tilt, or a seasonal, so this will never get closed. You can know that, okay, this is my place, and this is my point of injection, and this is my transmission system. This you know, and this is a terrain you know, right? The structure always will be decided based on your modules. So until unless you are not clear about your modules, the structure design always changes, right? And how these are the unknown aspects till the developer will keep on ringing in their minds. And the way they approach is they started tying up with various suppliers, various technologies, and always in touch with the market and flow, which technology will be best suited getting into that particular financial model, what the basic assumption was taken during winning the bid. So coming to the standards, there are very clear standards set for modules, inverters, even transformers, cables. These are all very well set standards. Except I can highlight one standard what we faced when I was doing a due diligence for taking over some of the projects. I came to know that in module MMS structures, many developers, they don't even do stat analysis. I think stat analysis nothing but a strength and the structure rigidity test in a simulated way that this structure, whether it will fail or not fail at a given wind speed. So in India, there are various locations where there are high wind speed zones, there are medium wind speed, and there are low wind speed zones, 1, 2, 3. So based on some building standards, building specification standards, there is no particular standard applicable for MMS structure. So still the standard is referring to a building construction standard where developer take their own assumption and they go for modeling or designing their own structures. Obviously, depending on what modules they are taking, what tracker they are taking, what robots they are taking, there are so many variability as we understand. So some developers do STAD, some they don't do STAD, some developers do wind tunnel modeling, testing. There are so many things or options are available. But large and reputed developers who wants to prove that and the standard of quality should be very high, they always do wind tunnel testings as well. And then they go for project implementation because MMS structure has to stay for 25 years to 30 years. Modules also should stay, right? So what is the loophole is, there is no particular standard that every developer has to ensure that this is met or not, right? That is area which we can focus, or the government agencies or the tendering agency can say that, yes, meet these guidelines. But as I also agree that since SECI is not specifying very deep because they are not the owner of the assets. They are buying the electricity and selling it. I accept and I completely respect their opinion. The one improvement what I see in the entire BOS is the MMS. If MMS is okay, because based on the cost pressures, steel prices and everything, developer may compromise in some aspects. One example I want to say, in a seasonal tilt, what I observed in one of the case is in peak summer season, the tilt could be like facing to the sun, the angle will be less. In the December month, the angle will be like 24 degree, okay? For the same location, if you apply the standard at a 47 meter per second wind speed, when the angle is say 24, the structure will fail. But we know that there is a high wind season, there is a low wind season. Obviously, during say April to September, that's a high wind season. So during that season, the angle of the module is at say 2 degree or 5 degree or 7 degree. Then that 47 meter per second will pass. So you can think that how deep the developers are going and taking an assumption that during my low wind season, the high wind will not happen. If it happens, what will happen to those projects? These are some of the things what I observed, so that there are several developers who are getting into the business. The entry barrier is so low, anybody who has money can enter into the business. And just to win the bid, they can go at quote at a very low price. And what, from an energy security point of view, since India is progressing towards solar and wind and whatnot, so all the technologies are going to happen, and we will phase out this thermal plants by 2050, I believe, right? Even I worked in NTPC, so I'm saying this. So when this is happening, and the tariff fighting is happening, so as policy makers and the regulators should give focus that due to cost pressures, developers should not compromise on quality on MMS structure. Rest all the equipments are very fair and straight and simple, which cannot be manipulated by anybody except the structures. That's what I want to say. Thank you.
It's interesting that both of you went straight to mounting structures because, as you said, no standards exist for mounting structures at all. Yeah. Mehul, I'll come to you. So inverters is a very important part of BOS systems. Uh, there have been some attempts by MNRE to implement quality standards. I think the effort started way back in May 2017 or so.
Right.
Since then, there have been 13 or 14 extensions.
Right.
Could you throw some light about what's the latest on that?
Sure. Hi, my name is Mehul, and today I'm representing TBEA. We are into utility inverters. Now, there are two technologies of inverters on a broad way. It's central and string. So, in terms of policies, inverters are inverters, and what generally industry is following is IEC and IEEE standards. However, there is an additional standard which is BIS. Now, when it comes to BIS, for inverter guys like us, it's like a complete dark area because BIS standards, although the procedures are mostly similar or sometimes same as IEC standards, but any inverter above 100 kilowatt, it is very difficult to get it approved through BIS because the labs are not there. Now, we personally had several meetings with BIS teams and other agencies, and we said we are, as an industry partner, we are ready to do it. If we can pass IEC, IEEE, we are very confident that BIS standards will also pass because in several tenders it comes as a mandatory requirement. So they said, okay, we'll work on it. Now, one of the issue with the inverter industry is that since like everyone knows and has already talked, that irrespective of what is the price of modules or structure, the bid price or PPA price has been a downward slope. Now what happens is everyone is left with a target. So that bounds everything, whether it is technology or the standards to be followed, that this is the price, this is the cost per megawatt we have to do, and let's do what has to do. Now, when it comes to optimization of the BOS, inverter plays a very important role because the block size and based on block size, the cable sizes, transformer sizes, and couple of other components, everything is decided by the inverter. That if inverter will be of specific rating, this will be the AC block, subsequently transformers and other things. Now, inverter size has been increasing to reduce the BOS cost. So, for example, we started with the 500 kilowatt, initial utility were 500 kilowatt. And presently we are supplying 5 megawatt. So, it's a 10 times increase in the size. So by the time BIS standards were ready for 500 kilowatt, those inverters were already out. We were supplying 2.5. Then they said, okay, we'll set up our labs for 2.5. By that time, 3.125 inverters came in and the block size was 12.5. By the time 3.125 became a norm, now we are moving to 4.4 and 5 megawatt inverters. And the reason all of this is happening is to optimize and bring down the BOS cost. So that's the basic idea. And every year we just get an extension that, okay, there's an extension that is followed. Like it has been clearly said, it's been 11 or more than that extensions. And every year we wait for it. Projects get commissioned. The only challenge in the terms of execution that we fail is if on that particular date your extension has expired, it takes another 10 to 15 days. And you cannot charge the line, you cannot go ahead with it. I believe that's one area where, as an industry, we all need to work. And the BIS standards, they need to keep up with the technology and size improvement that's happening. And this will continue to happen. So change at a faster rate is required on the agency part. So that's my take on it.
Sure. Satish, so all of the risks that developers and inverter suppliers may take, basically developers, with respect to design and choice of inverters, mounting structure, etc., a substantial share of that risk falls on the O&M contractor. Uh, if you could share any specific examples of some of the challenges that you have faced, which may be attributable to quality of the equipment chosen by the developers.
Yeah, good afternoon, everyone. So, in terms of the BOS part selection, most of the time, like cost cutting is majorly on account of only BOS, not on the some capex, which is considering like 60% cost of project cost. So, say one of the example for cable or connector, which are very basic in nature, but they have a like a huge impact in terms of the uh, your safety aspect basically. So if you are connecting the module with the inverter with like some low cost of connector, so the fire chance and the operator which are like doing the cleaning during the night time, so maybe some discharge may takes place, and that is like some incident have happened due to like low quality of the connector. So this kind of risk may be eliminated at the time of uh, designing stage if we have a dedicated some standard with respect to India, since all are like governed by the like some European or US kind of, but none of the standard are specific to the like Indian kind of the climate. So like if we talk about the like Rajasthan case, and if we talk about the like south like Pavagada, the weather is completely different for the BOS point of view. So if we have a like any standard, whether it is governed by the like a BIS or some other agencies, that can like control so that everyone should be on the same page, that bare minimum standard everyone should be follow. So since like standards are not available, everyone is following the IEC, and now BIS is taking the IEC standard which are like 4 year, 5 year old. And so what happened like if you are going to install the plant, you either you fulfill the IEC standard or BIS. But nowadays BIS is a mandatory. So you have to follow the BIS, which is like 5 year old. So if you are bidding like a project which will last for 25 to 40 year, so you have to be updated timely, and you should be like a 5 year ahead. So if you would like to make a quality project in India, because that huge like huge energy market generated by the solar, and by considering like 2030 or 2040, if we have a like like transforming from conventional to the solar, so we have to have some India dedicated to the Indian specific kind of like standard, which will eliminate these like minor plus major risk associated with both as a like a ROI as well as the safety. And then if we are investing the like money in the solar, that will also help you to like better return if you have a quality project. So that's the like short input on the risk mitigation point of view from my side. Thank you.
Mr. Reddy, Satish mentioned that even if the developers follow IEC standards, they may not be specifically designed for Indian conditions. Within India, there are several types of regions as well with respect to wind, soil type as well. Uh, do you believe there is sufficient capability, capacity within India to transform very quickly the IE standards and make them suitable for Indian standards? I asked this question because Mehul had mentioned it is very difficult to get any inverter bigger than 100 kilowatt tested. So I want to understand whether capacity exists, capability exists within India to very quickly, within 1 or 2 years of, or so, to adapt IEC standards for Indian conditions.
Sure. As Satish said, there is some issue. We need to, because India is having a wide variations in the climatic conditions, that it will be very difficult also. So, but some of the things like in the modules, we made some changes according to Indian conditions. In module standards, we did some changes to suit Indian conditions. But in cables and all, connectors and cables, I think it will be difficult, okay, because in the early days, the people used to bury the cables, all the DC cables and all used to bury. The temperatures doesn't matter there. Okay, now people are doing DC cables in the open trenches, some blocks are there, the HDP blocks are there, something like that they are doing. So means even the installation procedure is changing continuously. Only the cable standards are pretty much means established actually. I think we can follow those things. But only thing is while sizing, the developer need to take care of the temperatures of the location and all. Based on that, you need to size the cable. That there the compromise is there. I think in your report also it is there that instead of copper, people are going for aluminum. Okay, no problem. You can go for aluminum, but proper sizing is required. And also when you go for open cables, you must think of how about the UV degradation of the insulation there. Okay, so all the cables are there or not for the they have to last for 25 years. So that is very much required. Earlier in olden days we used to use conduits and underground cabling is there. Now it is open cabling. So we have to take care of those things. Standards cannot address all the problems. That is the thing. Coming to Mr. Mehul issue, it is a pertinent issue because even in the Ministry MNRE also wants to bring this BAS certification, wants to standardize. But in inverters, it is becoming difficult. There is no, in India, there is no capability because the sizes are continuously changing and mainly it need a big power source. Instead, all the inverter manufacturers together, they can think of having their own, many people are there integrating now in India. So even in China also, when we go for some inspection of the inverters and all, they don't have any central lab. So what they do is that they have their in-house lab. In-house lab will be tested by like agency like NABL here, the CNAS is there, they will certify that. So then based on that testing results, some agency like TUV or UL, they'll give the certification. So lab is certified, okay. So like that you can plan for, because for every changes, means any government, they cannot plan, okay. So that is, it is you the inverter players, whoever is assembling in India, so they have to take care of that. They have to develop their lab whenever they are coming out with a new higher capacity. They have to increase that. Main issue is the power source. 5 megawatt power source from where? So it is very expensive thing. It is not so easy. Also, means developing that competence is also is difficult. Okay, means even in Europe also, even in China also, people are doing like this only. Inverter testing is being done in the manufacturer's premises. We did the same thing for BHEL has developed something. We did the same thing in their lab only. We did the testing. Okay, so that is my suggestion there. Okay, otherwise it is not easy to solve that.
Mehul, we were discussing earlier that not only that the equipment needs to be tested, the testing lab needs to be tested as well, needs to be certified. As Mr. Reddy suggested, what we can follow the Chinese example, but I want to understand whether it is something that is easy for the Indian manufacturers, the companies present in India, how willing the industry is to go down that path.
Okay.
And what would be the impact on the prices of the inverters?
We have to understand, as a manufacturer, it's not like we don't have labs, right? Because every product that moves out of the factory gets tested for certain parameters. Now it is not necessary that these parameters follow the entire IEC standard, right? So in industry, we generally call it as FAT testing, factory acceptance test. the major points are being mentioned in that, okay, efficiency will be tested, heat run will be tested, the output curve in relation to temperature is tested. So a couple of IECs can be covered in our lab also. And the standards what we are following are same as IECs. So it is easy to get the certification also. But for inverters, it's not a single IEC certificate. For example, there is one IEC 61683. That's for testing the efficiency. Now inverter get tested at different voltages and at different loads, DC loads. And then there are certain ways how to calculate that this is the peak efficiency and this is the average or European efficiencies. Those things can be done. But that will not solve the purpose, because if we have to follow all the IEC certificates, for example, it's a safety. Uh, we might not have equipment to do that. We are not doing that test as a standard test before dispatching the inverter, because that we say we have been done. Yes, we can think about it. We can make a lab as a manufacturer, but I believe that will be a separate lab for us, because the lab or the testing bench that we have, that's for the production, right? And like I said, anything we produce, we test it and then give it out. And a lot of times in inverters, the capacity, like we say that we are now 6 gigawatt factory, the capacity is not on the lines, the assembly lines, but the material that moves out of the factory. That means the testing bench becomes the bottleneck. So it's already a bottleneck for me, because testing lines I can put very easily. Couple of more lines, we have space, we'll do it. But since to maintain the quality, testing has to be done. So those testing beds are already occupied with everyone. The same procedures more or less are followed by all the industry standards. So it will have to be a separate lab to do all the IECs, 61683, 51999, so many different IECs which corresponds to different standards. So at present, we as manufacturers, we cannot do all of them as of now. But yes, it's a good suggestion if some centralized lab can be done. But then it becomes a challenge to connect to all of them and say, okay, let's make a lab. Okay, I'll not take the entire cost. Let's top 3, top 4 people who are taking somewhere around 85% of the market, let us do it. They'll say, anyways, BIS extension will be there. So, uh, where to get that money from? So these are some of the actual on-ground challenges. Getting a lab certified is absolutely not a problem. So we would need government support in that, because we understand the change in the technology in terms of sizing is too rapid. It's like every time a new low is hit in PPA. Trust me, you look at the design of that particular project will be completely different, because they have done some calculation that, okay, if I bid at this price, my POS cost needs to be this. And gentleman has very clearly said that the 60% module, that cannot be controlled. So what's left with developers to go to BOS, right? So they'll do anything in terms of design optimization, increasing the size. And as the market moves, we have no option but to innovate, optimize, and then come up with designs.
Madhusudan, Mehul again mentioned 60% of the system, it sits on MMS, which costs just 5% of the BOS, but there are no standards for MMS. And we have seen over the last few years very adverse weather conditions, especially in Gujarat, Rajasthan as well, where some of the developers have faced issues, structural issues, damage to MMS and modules. Have the developers reached a stage where they have started taking into account the climate, the weather cost as well into their assumptions, or the competition is so much that it still hasn't arrived on their radar yet?
See, no developer knowingly does that. So it's an experiment. Like what if that works, what if that works, and how much optimize it can be done. It's always EPC proposes that this design will work, right? And developer, what they understand, okay, let us test it, simulate it, do a wind tunnel. They will do it. And if it pass, obviously they will go for it, right? But in a real life situation, it's not a simple simulation which happens. A tornado can come, or even a tower collapses, 220 kV tower collapses. So some unfortunate event happens. But it always triggers to a learning. So it's a cycle. So from a developer standpoint, we do have, like Satish was pointing out, the quality of connectors and cables. But from a developer standpoint, from an IPP experience, I'm saying if we happen to see one wrong product or a quality product which led to in a wind-up phase, we incurred loss because of this, what is the root cause, what is the root cause, then finally it will drill down to that supplier quality has to be ensured. If we ask why it was not tested, it will say it's not a critical item, it is a class C category item, so owner will never put a quality people to check that. EPC also will not check it. So it will surface, the teething issues will always surface, and it goes into the learning of the cycle. Again, the specification will be stringent and the checks will happen. It not only applicable for transformer, any unit generation loss, it will pinch us. Right? That developer is very, very careful in choosing why it went wrong. If some modules flown, obviously because of design issues, right? And even there are some designs like in Badla, we have experienced that the wind direction changes, the sand erosion happens, the movements of sand dunes happens. So it's a continuous learning. While it's easy that Rajasthan is a good for irradiation, there are so much of land is available. People are getting land close to the evacuation. They have to put their plant in sand dunes. And sand dunes can move with the wind directions, right? So it's a learning. And the structure designs, piling, everything is getting continuous improvement. So some failures is not a complete failure of the system. Even developer understands that and they overcome that. So I don't see there is an issue around that.
Satish, a similar question to you as well. As project has been set up, designed based on some assumptions, they may be risky in nature. How, as an O&M contractor, you take into account, you plan the risk mitigation for a particular project? Obviously, every project is different. Newer projects may have slightly more riskier assumptions. What is your approach with respect to the different uh, designs, project designs? And how do you mitigate the risks?
Yeah, so basically, as a project to project, for example, if we consider for a fixed tilt kind of approach, so for a fixed, the risk compared to like tracker or seasonal tilt is lesser. So we generally do some first level of due diligence of the plant and analyze as a historical as well. For the new plant, we will just go through the whatever they have designed for life and what they have assumed, and we based on our experience we can recommend that these may like fail over a period of time, or we can like suggest that we should take care as a like sometimes as a spare planning, so to mitigate the generation loss in terms of the like some C class of the items. And for the major one, we generally recommend that you have to like plan for the uh, spare like a for transformer or so for the inverter, which are like compatible with the some that area. For Rajasthan, if we analyze the plant which are having the similar kind of evacuation or similar kind of inverter to transformer voltage, we can make it like as a central inventory, which we can replace or as like a failed due to some internal issue or something that may be analyzed at the later stage, but we will try to mitigate their generation loss. And that part maybe sometimes we consider as a, like a owner scope, or sometimes it's a EPC scope during the DLP period, and that type of kind of we bifabricate as a O&M operator risk and as a like owner as well. So that's kind of approach we follow in risk mitigation plan.
Uh, Mr. Reddy, while most of the capacity in India is quite young, but there are some projects that have started completing 3, 4, 5 years or so. Have you started seeing any issues, quality issues, any impact on generation yet?
We are getting generation data also, means as we are paying for them, we are getting that, and we are not seeing much degradation or anything in the utility scale projects. But there are some projects in rooftop sector where we monitor it for 2 years. Their quality is not up to mark. There is a degradation. They are not meeting the CVF specified in that. That is the thing. And in last year, I think because of weather issues, I think throughout the country, the generation numbers are low. That is the thing. But there are some incidents happened that some projects has some these issues because of storm or something issues are there. Otherwise, there is no much in the things. But only thing in the structures, what I'd like to specify is that all the civil structures, they, whenever you do a building or you do anything, people work on some factor of safety. Even though it passes in the wind tunnel test, you must have the factor of safety. You don't know. You are saying that a region will have a 55 meters, 33 meter per second. That time, sometimes, especially in summers, the localized winds comes. Okay, so even in our own plant, some couple of modules got blown away. Okay, because structure is intact, but even the contact is whatever the fixing points are broken out from the modules itself. So it happens. So factor of safety is important. That need to be there. The people are compromising there. Okay, so that is the thing. But it happens. But anyway, as the developers are saying, it is always price pressure in the country. Okay, rather than the quality is the secondary, price is the primary means. So we have to live with that. Okay.
So just one addition to the Bharat sir, as we have standards for the like designing phase, so why not like India take a lead to generate a standard for the operation kind of, and do some regular monitoring through the like audit, similar to like a BIS is doing the factory audit. Similarly, BIS can audit the plant as well, and based on that they can benchmark the plant and take the like goods and bad for the learning, and that can be incorporated in the standards that will help to like through over a period of time, that will maybe uh, improve the design considerations, and that gives some specific numbers instead of generic open-ended. Maybe we can give some range. This range may be fulfilled for like designing consideration. That's one.
I would like to add to that question. So most of the standards that we see are related to either testing, quality, safety, etc. But nothing related, nothing that can actually help a developer, a designer choose the right equipment with respect to performance, design, etc. So is that something that you would be working on, or the government has started looking that this gap can be bridged, so that, like you earlier mentioned, having some ratings that can be straight away used by developers, that I can choose A, B, or C?
Most of the standards are equipment specific.
Yes.
Of course, there are standards for building code or something that we are adopting for civil. But for installation also there are standards. For transportation there are standards. But how best we are following, that is the main thing. Even I was there in our own plant. There is a, means in the standard itself, it has to say that you have to tighten the screws at 70 Newton or something. No one uses the torque wrench. Then what is the point of having standard? Standards are there. Even for O&M standards are there. How to periodically check, what are the parameters to be checked. All these things are there. In each and every project, you are developing your own O&M manual. What are the periodic checks, preventive maintenance, what are the things. But how best you are following even your own manual? That is the major issue. That is not being followed. But saying something and on paper and not following practically. That is the issue here. Okay, so everything cannot be solved by the someone, means like from the childhood onwards we have to, we learn like this actually. Until unless someone is pressurized, will not read and will not implement like that. So we have to, self-discipline is required actually.
Madhusudan, as Mr. Reddy mentioned, there are standards and everything. Uh, but as a developer, how do you ensure that your team and EPC and then finally O&M contractor, you are the owner of the project, how do you ensure that the best practices are inculcated throughout the value chain?
Right. So I will take an example of a project size of a 300 megawatt solar project. And we always hear that the people attrition, the manpower attrition is very, very high. Say for a project of 300 megawatt, you may need 2,000 people for some time, 1,000 people for some time, maybe 500 people working sometime. And these people will keep on coming, and 100, 200, 500 people will keep on changing for a contractors, right? This is one big challenge. And the skill set of those people, it's very, very challenging. There are some charts that, like Rajasthan, Badla, it's, you have several gigawatts in place and the ecosystem is developed. If you go to a place where ecosystem is not there, you will be the first person to get tested. And ensuring the quality, execution, construction, even laying a cable, and how they treat the cables. It will be on bundles kept on the roads, and some jeep can just pass over the cable, and they don't know what is the importance of the cable, and they can drag the cable on the soil. And we have seen one of the project that premier EPC partner, if I say the name, you will understand that, wow, this company, okay, so it's a high brand. But ultimately on the ground, who is doing the job? That company is not doing the job. Some labor, some contractor is doing the job, right? And who is owning that asset? And it is connected to the grid. One wrong practice in a large plant, right? 2,000, 3,000 acres of land, multiple people working multiple day and night to complete that schedule, to commission the project. People are working for the pressure and people are not available to work, ensuring quality and following standards. These are all challenges, right? And okay, you understand the problems now. What are the actions we are doing? We take some first outs or first do it first right. Some slogans we keep, and we demonstrate to the larger people every time. Any few people or 500 people are coming, we have to demonstrate how to do it right, what tools you need to use. Some people carry the module on their head as if they are carrying some bricks on their head, right? If they do like that, the module is gone. Okay, so there are so many challenges that developer has. We push EPC to do it, and EPC is also taking the same effort to do it. We use technology, obviously, we use thermography, EL testing, drones to see that everything happens. Today, construction monitoring, we use drones. And Satish himself created a mobile PV lab, right? We use that lab to see that the transporter has properly reached, modules are okay, properly stored, and properly shifted to the place where it gets installed. There are so many activities during construction that the owner has to see very, very carefully. Even being careful, it's not sufficient because we need to train people, such a large people, in a very short period of time. And people will not stay for 2 years. They will keep on moving. This is the challenge, right? In the O&M phase, I'm being a O&M function for a long period of time, I can talk about for hours. But to cut short, again, O&M contractor, once they come in, every project will have a different teething issues. There could be rats getting into the cable conduit, eating somewhere in the ground where it's an agricultural area, right? And there are, the cable strings will be falling on the ground. The cable ties. I was very curious to know, when they are designing a plant in the outdoor, such a large plant, if the cable tags will not last for 1 or 2 years, then what is the fun in having this much activity? O&M contractor, how many people they will deploy? When you have 1,000 people to erect the plant, 10 people, how they will manage that cable ties? Right? So there are some quality issues if it's simple tag, cable tag. Right? For a UV irradiation, it will fail in 2 years, 3 years. So these are small things happens, and this is the learning which we carry on. I'm sure that every company has lot of learnings, and those learnings convert into our actions and gets into our manual and gets into that. That's why some people achieve 99.5 about, some people achieve 99. There are KPIs, matrices which clearly define you which developer is doing what. And Satish's suggestion is also valid. We were also trying to engage DNV, TUV to make a standard to evaluate different projects, evaluate that and ranking it. So there is a long way to go, but obviously learning keeps on happening. And technology changes will always keep you on toes. Yeah.
Mehul, Mathusudan mentioned about technology. We were discussing earlier regarding some developments in the inverter technology with respect to IGBTs now being based on silicon carbide and gallium nitride. If you could share some developments regarding that
Sure.
and how such inverters can help developers.
Okay, so inverters, as we understand, is the we would call as the heart of the plant, because like everyone is talking that the tariffs and the uptimes needs to be generated. And if inverter stops, the game stops. Okay, so no units generated, uptime is gone, and that hits the partner who is doing O&M. Ultimately, comes back to the developer. So with inverters, anything that we do with the technology, we have to be very careful. We have to be 100% sure. And one of the major points which I believe everyone is saying, that there are different regions and the conditions of each region is different. So you cannot say that one standard is applicable for an entire India. Like Rajasthan, a lot of plants are coming, and I believe uh, what Mr. Madhusudan said, that Rajasthan, okay, the land is cheap, land is available, I get a single plot of land, the topology of the land is good, let's put and go ahead. But if you come to Rajasthan, look at the temperature conditions. So look at the other conditions in Rajasthan. Those, they become a challenge. In IGBT, now we are changing to newer technologies. And these are very promising technologies where we are moving. And in terms of switching, the IGBT does the switching from the DC to AC. The switching losses and size, they are better. That means the efficiency of the inverter will be more. Second, the size of the IGBT will reduce, and it is estimated that approximately 30% of the size will reduce. So that means that the power density of the inverter will be more. That means the inverter platform or civil work will be less. So these are upcoming technologies. We are very excited to work on it. However, these technologies have not been tested on a larger scale projects yet, and that too in India, and that too in stress conditions like Rajasthan. So for example, we tested a couple of IGBTs which were doing very well for us. So I took one of the IGBTs in our lab which was being used in a plant in Europe, one specific brand, let's say brand X. I put that brand X in Rajasthan project. Those IGBTs, the characteristics and the behavior was drastically changed because of the dust, moisture. In last couple of years, Rajasthan, the rainy season, the rain has been very drastic. It's a dry place, but those short tenure of time when the rain happens in Badla, it's a mess. A lot of people have seen it. The angle of rain, the intensity has increased. The overall water level probably might be same if you say that this much centimeter of rain happened in this year. But the tenure in which happens, it's like huge. These are a couple of changes that we have observed. So these new technologies need to be tested in tough conditions in India. And based on that, when we are very confident that as inverter suppliers, we are promising that in terms of uptime, generations and efficiencies, only then we'll roll out on a larger scale as a utility partners.
Thank you, Mehul. Before I take the final remarks from our panelists, I would invite the audience if any of you have any questions for the panelists. No problem. Yeah.
Hello. Yeah, I'm Ajay Todi from Gloucester Limited from Calcutta. As a layman, as we are setting up a rooftop solar for our unit, my question is that when I ask a bid for a solar rooftop for the unit, is there a standard in terms of I like what should be the quality of a cable? What should be the quality of the inverter? What are the parameters that I should lay down? Like as a user, there is a lot of ignorance, I admit. So someone tells me a Sungrow is good or a Delta is good or whatever inverter is good, and same for panels. So is there some reference point that one can take to make a bill of materials which can be offered?
Yeah. Mr. Reddy, would you like to take that? Just
And
before you
forgive my ignorance if it's a stupid question.
No,
But
no problem.
yeah, please.
Just before you answer that, MNRE recently issued draft quality standards, very detailed standards for rooftop systems. Yeah, please.
Sir, as Mr. Mridul is saying, there are standards specified in earlier documents also. Now very much detailed standards are there. Choosing which module, which inverter, means all the inverters are means standard, they are qualified as per the standards. Most of the modules are qualified. So you can choose anything. Main problem is not the module and inverter. Means any buyer, even I also think that means I need to go for a good product. But in case of rooftop projects, apart from the components, no module, inverter, or whatever, the rest of the things are important. How your cabling is done, how your earthing is done, those things are quite important. Any combination will work for the system. But the rest of the things, if your structure is not proper, it will blow away. Okay, if your earthing is not good, it will spoil the system. Not only spoil the system, it completely spoil your house also, your factory also. So these things are quite important in rooftop. Components, any combination you take, we don't have any issue. That's my view. I think actually people are there, they can specify.
So I want to answer like a layman because I have not worked in rooftop. If I want to put any rooftop in my own factory, assume it's a factory or even a residence, if I don't know anything, what I should do is at least take 4 or 5 reputed partners to do that complete study and take the quotation with a full bill of materials with standards and all, right? Understand the comparison and then talk to any expert, anything where you will get to know this is different clearly, why that is the different. Always you can refer back to a standard mentioned in MNRE or anywhere and then see the cost comparison and gain comparison and safety. And I discussed with some of the rooftop O&M players where they were saying there is no lifeline. Putting a rooftop is not great. It has to live for 25 years. If there is a shadow, your generation is gone. If nobody is inaccessible, it is useless. So there are so many factors involved, depends on the location where we are planning to do. So try to at least compare 3 or 4 vendors. Like buying a car, you do the same thing. And this is not a rocket science. Anybody can understand that.
Just to add to it, I'll add another point to what Mr. Madhusudan has said. From inverters perspective, I saw a couple of rooftop plants and major 2 challenges what I saw in terms of inverter selection. Number 1, the sizing is never right. Okay. For example, they say that my roof is 10 kilowatt. What is the nearest inverter you have around it? It might be 8, it might be 7. They say just put it and let's go. Okay. That's a lot. That's not the optimized practice. You are already putting the modules, but you are restricting the generation based on the sizing. So rather than that, what you can do is you can go for a little higher sizing, because the output from an inverter can be controlled. It can be reduced. Uh, in a very simple language, inverter is a current generating machine. And we have this facility that inverter has kind of a regulator. Okay, you can reduce the current, set it to a lower point, you can make it to a maximum point, that becomes the rating or overrated current. So you can go for a little higher, number one. Number two, a mistake I have seen from inverters perspective in a lot of rooftop plants and factories is there is something known as PID protection. Okay, uh, in a lot of rooftops which are in Gujarat, Rajasthan area, PID will happen. That is the degradation of the modules. And inverters have a feature where we can either stop the PID or we can reverse the PID. Which there are two, these are two basic ways to control the PID, which is potentially induced degradation in modules, which happens more in hot and humid areas. And what happens is, the as owner, PID doesn't happen overnight. It takes place after a year, 2 year, 3 year, depending on how the weather conditions is and how the plant is maintained. But once this PID start, you will say, oh, my rooftop earlier used to give this many units, 6 units. Now per day, per kilowatt, now it's only 4. So it's not the inverter. Inverter is a converter. Whatever you feed to it, the same thing after certain losses will come out. Those losses generally are between 2 to 3% on ground level. So if you feed less, the output will be less. And why you are feeding less? Your modules are there, but they are already degraded. So always check with the EPC players or come back to inverter suppliers, that is PID mode on in it, is my module safe, because inverters have this capability. So if you follow these two, and like said, the very common basic thing, if I don't know about anything, I'll compare for and ask questions. You'll get most of the answer out of it.
Thank you so much, Mehul. We are completely out of time. I guess to summarize, like there is a plethora of standards to be followed, there is a plethora of problems that everyone across the value chain faces. I guess the best would be to continue working on the low-hanging fruits, the easier problems that can be immediately addressed, and eventually, as Mr. Reddy said, probably someday we will have some kind of rating system like we already has for electrical appliances, which even residential consumers, developers, large developers can also easily follow, and they can choose the best equipment that can last the entire 20, 25 years of the operations. With that, I thank all the panelists for taking out time and patiently sharing their thoughts. I also thank the attendees. Thank you.
All right, ladies and gentlemen, that was a wonderful session. I would like to thank our moderator and all our panelists, Mr. Mridul Chadha, Mr. Bharat Reddy Yalasri, Mr. Madhusudana, Mr. Satish Pandey, Mr. Mehul Sharma for joining us here on behalf of REI. Thank you so much for taking your time out and joining us here. Hoping to see you guys next year as well. Thank you so much, everybody. Thank you.